Hello everyone, we're focusing on Unit 1, Lesson 3 today. To get us started on fossil fuels, I have a fun song that you can listen to, so make sure to get up and dance. Go ahead and pause the video, push play, and listen to this song. How are fossils formed? So if you were in class live today, we would grab the mic and have a few of you share. But since you're watching the video, go ahead and grab your science notebook and jot down there in your notes for today how you think fossil rocks are formed. Here you can see our calendar for January, and you can see today your lesson is lesson 1.01. So here on the 8th. That is your goal, is to finish the first lesson in Unit 1. Here you will see our scale that we have been working on for the unit. Remember, this was introduced to you in the last lesson, Unit 1, Lesson 1, and our goal is to get to at least a B on the scale. So use your science notebook and mark where you feel you are on the scale today. Here you're going to see a diagram of fossil fuels and how or where you would find them within the earth. Remember, fossil fuels form from those fossilized plant matter and bodies of small marine organisms. The dead organic matter changes because of the heat and the pressure underneath the earth. So over years, these remains become fossil fuels and are used as oil, coal, natural gas. Those are our most used fossil fuels today. They make about 90% of the energy that non-renewable resource energy that we are using in the U.S. These resources are abundant in North America with the vast reserves also found in other places around the world. Removing fossil fuels from underground is a challenging task, and we'll talk about that in a few minutes. But if you look here at the screen, you can see a diagram where they're trapping those fossil fuels under the ground. So here's all those dead animals and the plants here underneath the soil, and then down far underneath you'll see those fossil fuels that are trapped. Again, you can see the different types of rock that you could find under the soil. So if you are seeing, or if you were to see sedimentary rock or impermeable rock, you would still find those fossil fuels underneath. So here you can see coal, oil, and that natural gas. Now remember, plants use the sun energy to grow and survive by using photosynthesis. When an animal eats a plant, the energy from the plant is passed on to the animal. And this way, energy becomes the earth as light and heat from the sun. So just like when we studied about our food chains earlier in the year, we know that the food chain always begins with a producer, which is a plant that is producing photosynthesis. And we know a plant has to have the sun to live. That energy from the sun is helping perform that photosynthesis. Plants and animals use and store the sun's energy in their bodies. When they die, the energy is still stored within their bodies because energy cannot be destroyed. It is always reusable. Over time, organisms' bodies are compressed to become fossil fuels. Since energy is not destroyed, we can access the energy they stored when they were alive. By burning fossil fuels, the energy is released into the form of heat. Here you're going to see the three most important fossil fuels. We have coal, natural gas, and oil. Fossil fuels are used to heat homes, run power plants, fuel cars, and there are all other types of oil, but petroleum is the only kind commonly used to power machinery such as cars, ships, and planes. Here you can see another diagram. This is how coal is produced. So at the top of the diagram, you can see the forest that lived long ago. And as animals and these plants are dying, they're buried and compressed under the soil, and then that coal is formed underneath. Here we see a map. This is a map of the United States, and we know that the U.S. holds 1/4 of the world's natural coal reserves. So 1/4 meaning 1/4 of the world's natural coal reserves are found here in the U.S. All these purple areas, those are where you could find some of those reserves. So do you live in a purple area? All the students at OVCA live in Oklahoma. So we would look here in Oklahoma. We can see in the northeast side of the state, and kind of mid here area, we do have reserves. So do you live in that area? And if you do, have you seen signs of coal mining where you live? So scientists and engineers have made huge tunnels in the ground in areas where there's coal. So if they see an abundance of coal, they dig these coal mines. And in the coal mines, the miners grind up those coals, the coal deposits, and they transport them out of the ground. And then we use those, we burn those to use for energy. And like I said earlier, we use that for a lot of different things, to heat our homes, for electricity, things like that. So here are some pictures of some coal miners. We have some more recent pictures and some pictures long ago. If you look at this one up here at the top, you can see the horse pulling the coal, and the coal miners there. Where here below you can see more of a recent picture where a coal miner is chipping away at some coal. And now you can see that they have a more updated way of transporting that coal. So these are hard workers, and this is a very dangerous job. Would you want to be a coal miner? If you recall that coal forms mostly land-based dead plant material is compressed by the weight of the sediment in the oceans. So remember, when that plant and animal dies, the material in that soil is pressed down, and the weight of the soil and the water is what helps form that coal. And petroleum and natural gas they form in much the same way. However, they form when tiny marine organisms die. So if it's a marine organism, you're going to find those in the ocean. Imagine an ancient marine environment where tiny marine organisms such as plankton and algae die and sink to the bottom of the ocean. Their remains pile up and are buried under all of the sediment under the sea. Over years, a combination of heat, pressure from the water, and decomposition changes that matter into oil and gas. So here you can see where some of those pictures or diagrams of how that oil and natural gas is forming. Now, collecting the petroleum and the natural gas is not as straightforward as collecting the coal. Remember, petroleum is a liquid and natural gas is a gas. It's not so easy to dig these up and put them in a container for shipping like it was for coal. So take a look at the graphics below and it will show you how they work to pump this liquid or this gas out of the ground so that we could use that for energy. So you can see this pump goes way deep into the ground, and it reaches down to where you would find that oil and gas, and it's going to pump it up. If you live in Oklahoma, more than likely you've seen one of these pumps near you. Maybe if you're driving or even near your home. But these types of pumps are pumping that oil or that petroleum. Here's another picture of what those pumps look like. Now, natural gas is pumped differently, and those rigs, but they do go down into the ground and they pump them out, and you just have to be a little more careful. It's not as easy to keep those in contained. Here you can see some pictures of some of those, of them pumping some of the petroleum and gas out from underneath the sea. So here you're going to see a bar graph. What could you infer from this graph? Okay, so it may not tell us exactly, but if you look at this, what could you make an educated guess about? So it's showing us the world energy use and production in 2001. And it has the different, down here along the bottom, the different countries: North America, Asia, Western Europe, Eastern Europe, and so on. And the yellow is the use, and the purple is the produce. So how much they're producing versus how much they're using. So if you look here in North America, I can see the yellow line is more than the purple. So we're using more energy than what we're producing. Same in Asia, same in Europe, Western Europe. Now, Eastern Europe, they're on the positive side. They're producing more than they're using. South America, it's about even, maybe a little bit more, producing a little bit more. Look at the Middle East. They are producing a lot more oil and natural gas, or using, than they're using. And Africa the same way. So interesting fact. Was knowing that there are things that we can do as Americans to make an effort to change this, to improve where we are not using more than what we're producing. So I want you to think about some things that you could do to help conserve that energy. So jot some of those down in your science notebook. So some things that you may have thought of: maybe riding a bike, walking when you can, instead of driving your car, because we know that it takes energy to run a car or a vehicle. So that's one way we can conserve energy. Maybe you choose to turn down the heater and just put on an extra sweater. And you can conserve energy by not running your heat or your air conditioning as high or as much, especially in spring and fall when the weather is nice. You can just open the windows, or put on an extra sweater, or find a way to save that energy. Even little things can help conserve energy. Just the tiniest things can help. Make sure to complete lesson 1.03 in your course, and make sure, as always, to check your email in your gradebook. Thanks, guys.